Hello friends, here in this video we are going to see a problem on section of a square pyramid. Here is a question. It is given that a square pyramid of base 40 mm and axis length 60 mm has one of its triangular face on HP with axis parallel to VP. It is cut by an AIP called as auxiliary inclined plane passing through the center of gravity of a solid, which is the square pyramid, and inclined at 30 degree to VP. Inclination 30 degree to VP will be visible in HP. And removing the apex, the condition is given. Draw sectional elevation, plan and show the true shape of the section. Sectional elevation means sectional front view. Elevation is the other name for front view. So we have to draw the sectional front view. Plan means top view and show the true shape of the section. So first I'll draw the diagram of a square pyramid. So here we have the diagram of a square pyramid in which we have a square base. It has four corners. All the corners are connected to a common apex, point O. Then these corners are connected to the apex with the help of slant edges. Next, since it is a square pyramid, it is having four triangular faces. So these are the triangular faces. Next, in the question it is given that square pyramid of base 40 mm and axis length 60 mm has one of its triangular face on HP. It means the square pyramid, first of all it is in HP like I have shown in this diagram. We can say that this square pyramid is kept in HP, that is on the ground, and when we are keeping it on the ground, from the top view we are going to see the square base, and from the front view the triangular face will be visible. So it means in order to start this problem I need to draw the square in HP. So starting with this, so that square needs to be drawn in HP. Now square should be drawn in such a way that the pyramid should lie on its triangular face as given in the question. So for that I'll first draw a light line measuring 40 mm over that, because that is the side of the square. Measuring 40 mm, marking it onto the both sides. Joining these points. Joining the corners. Next, I'll give the notations to it. So this is the top view. Next, projecting the front view. The axis height is 60 mm. So on this projection of O, I will be measuring 60. Giving the notations in the front view: 1 dash, 2 dash, 3 dash, 4 dash, and here we have point O dash. Now I won't be making it dark first because another condition is there, and finally I would be making it dark after showing the cut section or the cutting plane. So now in the question it is mentioned that square pyramid of base 40 mm and axis length 60 mm has one of its triangular face on HP. So when the triangular face is in HP, it means that the square pyramid should lie on its edge. Like taking an example here it is resting on edge 3 to 4 because we are going to tilt the pyramid onto the right hand side. So if it is resting on this edge, and when I am going to tilt this pyramid, it will be lying on its triangular face O43. Otherwise, if I would have taken the other condition, that is instead of edge I would have taken the corner on which it was resting, then after tilting it, it would have been rested on the slant edge. So here this condition I have taken because it was given that the pyramid is resting on its triangular face. Next, when I look at this triangular face into the front view, it is O dash, 3 dash, 4 dash. So it means if I have to make this triangular face lie in HP with axis parallel to VP, for that case I will have to make this slant edge in line with XY. So for that I am selecting a point, measuring the distance from 4 dash, 3 dash up to O dash. Keeping it over here, marking it on XY line. So here I am getting O dash, and this is 3 dash, comma 4 dash. Then keeping the same slant edge, keeping the point on O dash, drawing a light arc through it. Next, measuring the base, keeping it on 3 dash, 4 dash, cutting this arc. Here I am getting that intersection point. Joining with the help of light line. For the axis from 1 dash, 2 dash to half. This will indicate the axis. Then this is the front view of that pyramid which is lying on its triangular face O dash, 3 dash, 4 dash in HP. Now looking from top, I'll be projecting its top view, that is looking the front view from top, and for that those points needs to be projected first which are closer to the observer. So point 1 dash, 2 dash are closer. So point 1 dash and 1 where they will intersect, that will give me the first point. For 2 dash, and here there is point 2 where they intersect, that is point second. For 3 and 4, where 3 and 3 dash they intersect, that's point 3. Similarly 4 dash and 4, that will give me point 4. For the apex, drawing a light line, and from the front view I'll be taking this point O dash. So wherever O dash and O they intersect, that will give me the point O. Next, joining them, light as an observer when we are looking from top, O dash 1 dash and O dash 2 dash are visible. So joining O to 1 and O to 2. As an observer, the edge O dash 3 dash and O dash 4 dash, which is forming the triangular face O dash 4 dash and 3 dash, that triangle will be hidden. So here O to 4 will be connected with the help of dotted line. Similarly O to 3 will be connected. With the help of dotted line. Next, now I'll read the condition for the cutting plane. It is cut by an AIP, that is auxiliary inclined plane. That plane is inclined to one of the planes and parallel to the other plane. Like here it is passing through the CG, center of gravity of a solid. Now center of gravity of this pyramid is, since here the height is 60 and CG of the pyramid is located at h by 4 distance from the base, so h by 4 of 60 is 15 mm. So 15 mm from the ground or the base, there is CG denoted as point G of the square pyramid. Next, this CG needs to be marked here in the second condition. So measuring the distance from the base up to the CG of the square pyramid, and here it will lie on this line. So this is the CG. Either it is for any kind of a pyramid, the CG will be located as at h by 4 distance from the base. Even for the cone it is at h by 4 distance, but for cylinder it will be at h by 2 distance. So at h by 4 distance I'll mark it. This is 15 mm, which is nothing but h by 4. Distance. Now it is given that it is cut by an AIP auxiliary inclined plane passing through the center of gravity, that is CG of a solid which is a square pyramid. We have marked the CG and inclined at 30 degree to VP. Inclination with VP will be seen in HP. So here I need to project this CG because the cutting plane is passing through the CG inclined at 30 degree. So first CG needs to be projected in HP because inclination with VP will be seen in HP. So here I am projecting this point G in the top view. Now here this is 15, it means it is showing the true length, but in the top view that length has become apparent of the CG. So I have to take this point as the CG and then pass the cutting plane. Cutting plane will be passed depending on which part is to be retained and which is to be removed. So now cutting plane is inclined at 30 degree to VP and it is given that removing the apex. So for example, if I am keeping this end of the protractor on the CG and if I am measuring 30 degree on this side and drawing a light line, that is a cutting plane line, then apex will not be removed, this bottom portion will be removed. But if I measure the angle from the other side, (30 degree), now if I join this, so this is the line which I am getting, which is the cutting plane line, and as an observer here, we have to see which part is to be retained, which is to be removed. Here in the question it is said that removing the apex. So we need to remove this much part which is closer to the observer. So I'll draw the section plane line or the cutting plane line. And whatever portion is there below the cutting plane line will be removed because apex has to be removed. If in the question it would have given that you have to retain the apex, then this cutting plane I would have taken 30 degree from the other side, and in that case apex would have been retained. But here we have to remove the apex. So whatever is retained, that I'll make it dark. So this much is the removed portion and this is the retained portion. Next, after completing this, now I'll make this initial condition dark, that is after the location of the cutting plane. Next, after completing up till here, I have to draw the sectional front view because we have to draw sectional elevation, and for that I'll give the notations. Now where this cutting plane is cutting, it is cutting edge 3 and 4 at this location. I'll give that as point A. Then it is cutting edge 1 to 2 at this location, point B. O to 4 has been cut at this location, so this will be C, and O to 1 is being cut here, so that will be D. So projecting these points up, if I see here point A is on this same line where we have 3 and 4, so when we are projecting it into the front view at the same location, I will get the point A dash. Now even B is at the same location as 2 and 1, they are onto the same line, so when we have projected them, they will appear as a same point. Then C is on O to 4, so we have O dash 4 dash on XY line. Point C will be projected. Then point D is on O to 1. So O dash, it is on O to 1, that is O dash 1 dash. That gives me the point D dash. Next, I'll make visible portion dark. So joining A dash to C dash. Then C to D, that is C dash D dash. D dash to B dash. And B dash to A dash. So this is the visible portion, and this apex has been removed, that is ODC. This portion has already been removed, so that will be light and only this much portion will be dark. Then I'll draw the section lines through it. Marking 45 degree. So this is the sectional elevation, only this much part is visible. Then I'll draw the true shape of the section, and true shape will be visible in the front view. This section line will be made parallel with XY for the true shape. Drawing a light line. Next, taking the length of the cutting plane, that is the length up to which it is in contact with the pyramid. So from point A up to point D it is in contact. Here we have point A and D. Then marking C and B over it. So measuring the distance from A to C. And measuring the distance from A to B. Points B and C. Projecting the points one by one into the front view. So starting with point A. Point A will be projected vertically up, where A and A dash is on XY line. Their intersection will give us the point A double dash. After getting point A double dash, I'll project point B with a light line. and projecting B dash horizontally. So where B and B dash intersect, that will give me B double dash. Then point C. So where C and C dash intersect, that will give me C double dash. At last point D. D, and here we have D dash. So here we have D double dash. Then joining these points in the sequence, then drawing the section lines over this section or cut section. So this is the true shape of the section. Then I'll make this cutting plane dark. This is cutting plane A dash, and this is the viewing direction. Similarly here. A dash. This is the true shape of the section. Next, giving the dimensioning to it. Axis length is 60, and here we have shown all the conditions, and with this we complete the problem.